All right, welcome to the Unit 7 pre-assessment review video. This is question number 1. There's 3 possible points. What are those 3 points from? Here, let's zoom in so you can see that. So work that could lead. So that means if you did the work correctly, you just did calculations wrong, that's a point. Correct answer is a point, and an equation is a point. All right, so let's see. It says if it takes 1/5 of a can of paint to cover one wall, how many walls can you paint with 2 cans of paint? Solve the problem, show your work. So I have 1 can of paint, and it just takes 1/5 to paint one wall. So that means 1, 2, 3, 4, 5 walls per can. 2 cans equals 10 walls. What's my equation? My equation is 1. No, it's 2 divided by 1/5. So I have those 2 cans. I'm dividing them into 1/5 groups, and then that is equal to 10. All right. So you'll see for skill 1, I think that's this one, and then another one coming up. This is a different skill. There was 1/4 of a cake for John. Same thing though. Good work, good answer, and good equation. 3 points. There was 1/4 of a cake for John and his 3 friends to share. If they split the 1/4 of the cake evenly among them, how much of the original cake did each of the 4 kids get? So here's my cake. There's 1/4 of it left. That's cake. All right. Him and his 3 friends are going to share it. So that's going to split it into fourths. So that means each kid is going to get this piece right here, which is 1/16 of the cake. And what is the equation? That is 1/4. Oh, wait, no, sorry. Yeah, divided by 4 equals 1/16. I guess another way you could think of this is you could think of it as 1/4 of 1/4, and that also equals 1/16. Either way. All right, cool. So again, if we look at the skill, right? Can we divide a whole number by a unit fraction? That was the first one. We continue down on 5C. Can you divide a unit fraction by a whole number? That was number 2. And then it continues to 5D. Can you divide a 3 or 4 digit number by a 2-digit number? This is coming up here. Also, can you figure out and explain how to best treat a remainder? Okay, so that's kind of the next skill. It's all about division and remainders and how we use those. So let's find out what that looks like. Miss Hall's class is planning a water balloon fight. Fun. They find 2,498 balloons. Wow. Who counted all those? Oof. How many water balloons will each of her 28 students get if they share them equally? All right, so you can do ratio tables, partial quotients, something like that. That's what I like to do. It's the one that makes the most sense to me. So we have 2,498 divided by 28. So what I want to do is I want to think how many groups. I want to use my knowledge of multiplication to help me out. So if I have 10 groups of 28, if each kid got 10 balloons, that would be 280 balloons. Well, we have way more than that. But if it was 100 balloons, that would be 2,800 balloons, and we don't have that many. So it's going to be less than 100. What about 50? 50 is like 1,400. That might be a good way to start. So again, 100 is 2,800, and I'm going to start with 50 to get to 1,400. I'm going to subtract. All right, so now we have 1,900. If I gave every student 50 balloons, we'd have 1,098 left over. I can still give at least 1 balloon to each person now. So how many more? If I do 25, that's going to be half of this. That's 700. 8, 9, 398. Again, I can still give more out. Half of 700 is 350. But you can't give 12.5 balloons. It would have to be a whole. So what about, 10 is 280, 20 is 360, right? Wait, did I mess something up? 10 is 560. 560. So I can do 10 here to get 280. And I'm losing spots here. 118. So what half of 10 is 5. That's going to be half of 100 is 50, half of 8, 59. Wait, what? See, this is what happens when I get tired. 140. That would be 5. Come on, Mr. Light, get a grip here. So it's not 5 because that would be 140. Sorry, that's the afternoon. And you don't have much space here, do you? So let's see. 2 is 56. So 4 is 112. So let's do 4. Right? Man, I'm way off, aren't I? 2 is... No, 112. That seems right because 112 and 28. So 2 is 56, so 4 is 112. So that means 6 are left over. So I have 50 plus 25 is 75, plus 10 is 85, plus 4 is 89, with 6 remainder 28. So I have 89 whole, and then I have 6 balloons left over. Whew. Oh, man. So that's 2,498 divided by 28 equals 89. Remainder 6. Explain what you did with the remainder. So in problems, in real world problems, if we have remainders, we have to make a decision. I have 6 balloons left over. Am I going to just give them to 6 people? No, that wouldn't be fair. Wouldn't be justice. So I'm just going to put them back in the closet and keep them for another day. That's what I'm going to do. So again, you have to think about the context and do that. So we have to have it work. We have to have a good explanation about what we did with the remainder. We have to have the right answer. Anything else to get points here? Let's look. 1 point for work that could leave, correct answer, equation, and the treatment of the remainder. All right, that's 4 points. Moving on. 789 students in Brown Elementary are going on a field trip. Each bus holds 32 students. How many buses do they need? So you could do a ratio table here. So if I have bus people, we have 1 bus gets 32, and I have 789. So if I do 10, that's 320. 20 is 640. So I still have what, 149 to go? So again, 10 is 320. 5 is 160, but that gets us too much. So what's 4? So 264. 4 is 128. So that looks like 24 gets us what? 768. And then we still have, if we had one more bus, so we have 24 buses, is going to carry 768 students, but we still have 21 people left over. They can't stay home. So our answer is this, is 789 divided by 32 equals 24 remainder 21, was it? Yep. So what do? We need an extra bus. We need an extra bus. You can't leave those 21 kids at home. Their parents would just lose it. So would the students. Just you can't do that to people. Alrighty. Here we go. 888 divided by 24. Again, depending on what you want to do. Divided by 24. So 10 is 240. 20 is 480. 20. 480. 804. So what? 10 is 240. Half of that is 120. So 360 is 15. 15 is 360. 8. We have 48. 2 more. It's 48. So then we got 0. So this is 20 plus 15 is 35 plus 2 is 37. So work leading and the correct answer. 1,424 divided by 89. 10 is 890, so I'm just going to go start there, I think. 890. 4, 3, 534. So what half of that would be 445? So let's do 5. 445. So that's going to be 9, 8, 89. Hey, that's one more. It's 89. So that's 10, that's 16. 16. 6 divided by 1/2. So again, all of these is showing work. So if I could say this is 0, this is 6, 1, 2, 3, 4, 5, and then I split each one in half. How many halves are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 halves in 6. And then I have a half. I'm going to split that into fourths. So that would be 1/8. Again, work and answer. Multiply each whole number or decimal by powers of 10. Use the example to help you. I'm going to pause this because I don't want you to sit there watching me write stuff. But actually, let's go back to the student thing. Let's see what we need to do here to do well. Where are we? Multiplies whole numbers and decimals by powers of 10. So it's just, you have to get it right. That's all. All of these next ones you have to be right on 6 and 7. And I think that is a skill in itself, right? 6 and 7. Yep, 6. Can you multiply and divide whole numbers and decimals by powers of 10? Do you understand what an exponent is? An exponent means how many times you multiply something together. So for example here, it says 42 times 10 to the third. And that's the same thing as 42 times 10 times 10 times 10. So that's 10 to the third, which is equal to 42 times 1,000, which is equal to 42 thousands. Okay, so here we go. All right, so A is 79 times 10 3 times, because that's to the third, which is equal to 79 times 1,000, because 10 times 10 times 10 equals 1,000, which equals 79,000. So 79 times 10 cubed equals 79,000. Let's look at the next one. 3,153 times 10 to the second. So that is 3,153 times 10 times 10, that's 10 squared, which is 3,153 times 100, which is equal to 315,300, because again, those digits are shifting 2 spots to the left. My 3 started in the thousands, it ended in the 100,000s, because that's 2 spots to the left. All right, 4 7/10 times 10 to the... So 4 7/10 times 10 to the fourth is 4 7/10 times 10, 4 times, 10, 10, 10, 10, which is equal to 4 7/10 times 10,000, which is equal to 47,000, because each of these digits is moving 4 spots to the left. So the 7 went from the tenths to 1, 2, 3, 4 to the thousands. All right, last one, 600ths times 10 to the fifth. All right, so here, this is 600. Ooh, I made a typo there. I said 6/10, and that's 600ths, which means that turns it to 6,000. All right, so we have 600ths times 10 5 times, which is 600ths times 100,000, which means my 6 moved 6 spots. 1, 2, 3, 4, 5 spots, sorry. 5 spots to the thousands. So I went from thousandths to thousand. So 6,000. Man, the afternoon, just not kind, is it? All right, let's move on. This is, again, the same skill. 78 divided by 100, that is 78 hundredths, because look, it's 78 divided by 100. 5.4 times 1,000, my digits are shifting 3 spots to the left, so that's 5,400. 3 27 hundredths divided by 10 hundredths, or 1/10. This is how many tenths are in 3 27 hundredths. That is 32 7/10. So there are 32 7/10 of 1/10 in 3 27 hundredths. 29 times hundredths times 100 is 29. 9/10 times 1/100th. So this is actually 1/100th of 9/10. So look, that you can write it this way: 1/10 times 1/100th, and what? That's 9 thousandths. So that's actually that. And then we have 251 6/10 divided by 100. So if I took this and put it into 100 different groups, you would have 2 516 thousandths in each group. Josh paid, so that's that skill. All right, for the next 3, all of your descriptions have to be talking about digits moving. We're not focusing on zeros adding, because we're not adding any zeros. Okay. So which one of these is right? If I have $30.90 for 3 shirts, is it $1? No, because that would be $3. Is it $103? No, it's $10.30. Explain your choice. So you just have to be reasonable. 10 times 3 is 30. So something like that. Olivia solved the problems below and got all the answers correct. Describe what is happening to the decimal point. The decimal point stays the same. It's always between the ones and the tenths, always. So you can talk about it, looks like it's moving, but it's not. The digits themselves are moving, okay? The digits are moving. Here, what is happening with the number of zeros? The number of zeros increases based upon how many tens we're multiplying by. I'm multiplying by 4 tens. How many zeros are there? 1, 2, 3, 4. I'm multiplying by 3 tens. How many zeros are there? 1, 2, 3. I'm multiplying by 2 tens. How many zeros are there? 2. That's because the numbers are shifting down depending on how many tens. So for every 10 I multiply, my digits shift 1 spot to the left. All right, so how did it go? Fill everything out, turn it in, and hopefully you got this all finished by the next session. I'll try and give people like 17 minutes so that they finish. Bye.